Welcome to the examples for the double angle, half angle, and power reducing angle formulas. In example 5, we're going to rewrite the expression in terms of the first power of the cosine. So that means if you notice the problem, it currently has cosine to the 6th. We only want final answers in terms of cosine x, where it's to the first power. And then we'll use a graphing calculator to graph both expressions to verify that both forms are the same. This is kind of a long problem, but if you can follow along with this, then I think you really have a good grasp of your power reducing formulas. Okay, I can rewrite the cosine raised to the 6th power of x as the cosine squared of x raised to the 3rd power, using my power to a power rules from my laws of exponents. Next, I can substitute the cosine squared of x as 1 plus cosine of 2x all over 2 using my power reducing formula. Next, I can use my laws of exponents to bring the numerator to the 3rd power and the denominator to the 3rd power. Now, the bottom is pretty easy. 2 to the 3rd is 8. But in order to get the numerator, 1 plus 3 cosine 2x plus 3 cosine squared 2x plus cosine cubed 2x, you could either write 1 plus cosine 2x out 3 times and distribute, or you could use the binomial expansion using Pascal's triangle. So the 3rd row of Pascal's triangle is 1, 3, 3, 1. 1 is the first term of the binomial. So in the first term, I'm taking it times 1 to the 3rd, the second term times 1 squared, the third term times 1 to the 1st power, and then 1 to the 0 power for the 4th term. But obviously, since they're powers of 1, it's not going to really make a difference in terms of the coefficient. Then going the opposite direction, I have cosine cubed of 2x, cosine squared of 2x, and then cosine 2x. So far, the cosine 2x is okay, but the cosine squared 2x and the cosine cubed 2x are still not first powers of cosine. So I have to continue. I factored out a 1/8, or I just basically rewrote the expression differently so that it makes my life a little bit easier in upcoming simplification steps. Okay, next, I substituted cosine squared 2x with the power reducing formula 1 plus cosine of 2, and since I had a 2x before, not a regular x before, I'm substituting that in over 2. Then I wrote the cosine cubed of 2x as the cosine of 2x times the cosine squared of 2x, because cosine to the 1st power times cosine to the 2nd power, I could add those together to get cosine cubed. Next, I did some simplification. 2 times 2x is 4x. And then I substituted, again, the power reducing formula of 1 plus cosine 2 of 2x over 2 for cosine squared 2x. Next, I distributed the 3, and 3 times 1 is 3, and then I could write that expression separately using its own denominator for 3 halves. And then I can distribute the 3 to the cosine 4x and write that over 2. On the other side, I simplified 2 times 2x to get 4x. Next, I took the cosine 2x and I distributed that. So cosine 2x times 1 gives me cosine 2x, and I wrote it over its own denominator of 2. Cosine 2x times cosine 4x over 2. Next, I started combining some like terms. 1 plus 3 halves is going to give me 5 halves. And then I can combine 1/2 cosine 2x over 2 with the 3 cosine of 2x to get 7 halves cosine 2x. Next, I factored out a 1/2. Then it's easy for me to deal with what's left, and I don't have any more denominators of 2. So I factored out a 1/2. 1/8 times 1/2 gives me 1/16. Then I used the product to sum formula for the cosine 2x, cosine 4x. Next, I distributed the 1/2 to the cosine 2x, and I distribute the 1/2 to the cosine 6x. Next, I factored out a 1/2. So when you factor out a 1/2, it's going to cause the 5 to double, the 7 to double, and the 3 to double. And last but not least, 1/16 times 1/2 is 1/32. 10 plus 15 cosine 2x when I combine 14 cosine 2x and cosine 2x. 6 cosine 4x, cosine 6x. This is the most simplified form of cosine to the 6th x, where I now have all of the cosines in terms of the first power of cosine. What does this look like on our graphing calculator? Well, I've graphed the cosines to the 6th x power. Now I'm going to go ahead and I am going to graph f2. So let's graph our results to verify them. I've already typed in our answer, 1/32, 10 plus 15 cosine 2x plus 6 cosine 4x plus cosine 6x to save some time. Now if I graph the original problem, which was the cosine of x raised to the 6th power, notice how we end up with the same function. So those two expressions are equivalent. Greetings and welcome to example 6, where we're going to find the exact value of the secant of the half angle. Recall from class that we are going to use information about the whole angle in order to determine the exact value of a half angle. So I have a triangle where we're referencing the whole angle theta, where the horizontal distance is 15 and the vertical is 8. In order to find the hypotenuse, I use Pythagorean theorem of 8 squared plus 15 squared equals c squared, and we end up with technically a plus or minus 17, but because it's a distance, we only need to use the positive 17. Now, we don't have a half angle formula for secant, but we do have one for cosine. So my plan of attack is I'm going to continue the problem using the cosine of the half angle formula. However, I'm going to take a reciprocal of our answer to find the secant of the half angle. If you notice in the problem, our x and our y are both positive. Therefore, when we have to determine if my final answer should be a positive square root or a negative square root, 8 and 15 are both positive values. Half of that would still keep the x and the y in the first quadrant are positive values. So for this problem, we do not have to worry about the negative portion of this formula. So the only thing I have to do is substitute in the cosine of theta, which is adjacent over hypotenuse, or 15/17. The remainder of the problem is simply getting a common denominator, dealing with a complex fraction, and simplifying a square root. So for my next algebra step, I can represent 1 as 17/17. Then when I add the numerator of 17/17 plus 15/17, it yields 32/17. Dividing by 2 is the same as multiplying by the reciprocal of 1/2. 2 goes into 32 16 times, so this simplifies into root 16/17 or 4/17. Now you're welcome to rationalize that, but remember that 4/17 is a simplified version of the cosine of the half angle. I need to take its reciprocal in order to find the secant of the half angle, which is root 17/4. And here we are at example 7. We're going to use the half angle formula to determine the exact values of the sine, cosine, and tangent. So let's look at 165 degrees. This is a second quadrant angle. And it's important that when we determine the sine, cosine, and tangent of 165, that the proper SIGN sign reflects a second quadrant angle. So that means that the sine will be positive, the cosine will be negative, and the tangent is negative. So please keep this in mind as we move forward. Next, how are we going to figure out this exact value of 165 degrees? Because it's not formed from a 30-60-90 triangle or 45-45-90 triangle. Well, 165 degrees is half of 330 degrees. 330 is an angle that we have information about. So using the 330 degrees, we can talk about the sine of 330 degrees over 2, because 330 divided by 2 is 165. So using the half angle formulas, I'm going to substitute in the square root of 1 minus cosine 330 over 2, keeping in mind 165 degrees is a second quadrant angle, so we're going to use the positive square roots. From here on out, and you will notice in future problems, this is just a matter of finding exact values and getting a common denominator, dividing by 2, by multiplying by a reciprocal, and simplification. So as we move forward in future problems, I might not show as many steps. So the first step that I'm going to take is I'm going to evaluate the cosine of 330, which is root 3 over 2. Next, what I did in the next step is 1 can be represented as 2 over 2. And then in the same step, I divided by 2, which is the same as multiplying by the reciprocal, which is a half. Next, I rewrote 2 minus root 3 . Next, I rewrote 2 minus root 3 over 2, and I multiplied it by 1/2 to get a 4 in the denominator. And then I simplified the numerator to be the root 2 minus root 3, and the square root of 4 is 2. So my final answer, the sine of 165 degrees, is the square root of 2 minus root 3 all over 2. Okay, so now we're going to follow a very similar procedure to find the cosine of 165 degrees. Again, 165 is the half angle of 330 degrees. So the cosine of 330 degrees divided by 2 using our half angle formula would be the negative, and we're using a negative because 165 is in the second quadrant, the square root of 1 plus the cosine of 330 degrees over 2. As we did in the last problem, the first thing I'm going to do is evaluate the cosine of 330, which is still root 3 over 2. Next, we need to get a common denominator, so I can represent 1 as 2 over 2. Next, I can rewrite 2 over 2 plus root 3 over 2 as one fraction. And I multiplied by the reciprocal of 2, which is a half, yielding me with the negative square root of 2 plus root 3 all over 4. I can give the numerator its own radical, the denominator its own radical, and so the cosine of 165 degrees is the negative square root of 2 plus root 3 all over 2. And last but not least, let's find the tangent of 165 degrees. And as we've done in the previous two problems, 165 degrees is the half angle of 330. So I can use the half angle formula for tangent, the tangent of 330 degrees over 2, which would be 1 minus cosine of 330 degrees over the sine of 330 degrees. You have two options. This was just the formula I picked. So again, as we did in the previous problems, I need to evaluate the cosine of 330, the sine of 330, and then you just have to do some common denominator work if necessary, and some complex fraction work. So when I evaluate the cosine of 330, I get root 3 over 2. When I evaluate 330, because it's a fourth quadrant angle, I get negative half. So then in the next step, I represented 1 as 2 over 2. In the following step, I rewrote the numerator as 2 minus root 3 over 2, and I multiplied by the reciprocal of negative 1/2, which becomes negative 2 over 1. The 2's will cancel, leaving me with the negative quantity 2 minus root 3, which I could rewrite as root 3 minus 2. And we have arrived at example 8. We're going to find the exact values of the sine of the half angle, the cosine of the half angle, and the tangent of the half angle, given information about the whole angle. So we're given information about the whole angle u, that its cotangent is 7, and that u lies between pi and 3 pi over 2, which would translate to the third quadrant. So I've drawn you a picture, and even though you see the cotangent of u is equal to 7, since it's in the third quadrant, your x value needs to be negative as well as your y. So that's why you see an x value of negative 7 and a y value of negative 1. if I do the Pythagorean theorem to find the radius or the c value, the hypotenuse, we know that it's root 50. Now, that does simplify into 5 root 2, but I'm going to encourage you to keep your radical unsimplified, because when we go get common denominators and simplify radicals within radicals in our half angle formulas, it really just makes it easier to keep the root 50 as root 50 in an unsimplified form. All right, so let's proceed to figure out, where does the half angle live? Well, if the whole angle lives between pi and 3 pi over 2, this implies the third quadrant. If I want to find the half angle, this means I have to divide all of those pieces by 2. And in doing so, u over 2, or the half angle, is going to lie between pi over 2 and 3 pi over 4. So that means that the half angle lives between pi over 2 and 3 pi over 4 in this region. So it's the second quadrant. Since the half angle lives in the second quadrant, the sine will be positive, the cosine is negative, and the tangent will also be a negative value. So let's use the half angle formula for sine to determine the sine of the half angle with the given information. So my formula is the square root of, and that is incorrect. All right, so let's find the sine of the half angle, given the information where the cotangent was 7 and we found information that the hypotenuse was root 50. So if I use the half angle formula for sine, it is equal to the square root of 1 minus cosine u over 2. And remember that the half angle lies in the second quadrant, therefore the sine is positive. So the cosine of u would be the adjacent over hypotenuse. So that would be a negative 7 over root 50. In my next step, I need to get a common denominator, so I can re-represent the 1 as root 50 over root 50. When I subtract a negative 7, that is going to become positive. And then when I divide by 2, it's the same as multiplying by the reciprocal of a half. Next, I just multiply the numerators across and the denominators across to get root 50 plus 7 over 2 root 50. And what I'm going to do next is rationalize. So I'm going to multiply the numerator and the denominator by root 50 within that big radical. When I distribute root 50 times root 50, is going to give me 50. When I distribute root 50 to 7, I get 7 root 50. And 2 root 50 times root 50 is going to give me 2 times 50, which is 100. The denominator is a perfect square, so my final answer is the square root of 50 plus 7 root 50 all over 10. All right, let's continue with the cosine of the half angle. Again, we're going to use a negative sign on the outside of the radical because the half angle is located in the second quadrant where cosine is negative. So the formula is the square root of 1 plus cosine u over 2. Again, the cosine is in the previous problem is adjacent over hypotenuse, which is negative 7 over root 50. Okay, I did not write in all of the work this time, but I got a common denominator of root 50 so that the main numerator would be root 50 minus 7 over root 50. Now I'm going to get rid of the complex fraction by multiplying by a half. So I get root 50 minus 7 over 2 root 50. And again, I'm going to rationalize the root 50 so that I get 50 minus 7 root 50 over 100. And the square root of 100 is 10. Therefore, the cosine of the half angle is a negative the square root of 50 minus 7 root 50 over 10. And let's finish up with the tangent. The formula for tangent is 1 minus the cosine of u over the sine u. So the cosine is adjacent over hypotenuse, which is negative 7 over root 50. The sine is the opposite over hypotenuse, which is negative 1 over root 50. I'm going to get a common denominator in the numerator of root 50 over root 50, yielding root 50 plus 7 over root 50, because when you subtract a negative 7, it becomes a positive. Then I divide it. Division is the same as multiplying by the reciprocal, which is root 50 over negative 1. When I simplify, the root 50s cancel. And I'm left with an opposite. And again, we said that tangent should be a negative value because it's a second quadrant angle of root 50 plus 7. If you wanted to distribute that out, that would be an okay answer as well. And we did it. We are at example 9, the last example of this video. We're going to find the solutions of the equation in the interval from 0 inclusive to 2 pi non-inclusive. Use a graphing calculator to verify your answers. So the sine of the half angle plus the cosine of x minus 1 equals 0. How do we even begin? I know I have a formula I can substitute in for the sine of the half angle, but how in the heck am I supposed to use it? Well, I'm going to get it by itself, the sine of the half angle, and here is why. The sine of the half angle includes a radical. In order for me to get rid of the radical, I have to have it isolated, because in doing so, I can square both sides of the equation, and the plus and the minus, a positive squared and a negative squared still yields a positive. So I am left with 1 minus cosine of x over 2. But you have to be careful on the right. 1 minus cosine x squared means 1 minus cosine x times 1 minus cosine x. And I have to first outer, inner, last that, which yields 1 minus 2 cosine x plus cosine squared x. In my next step, life would be really nice if I just didn't have a fraction. So I can multiply the left side and the right side by 2. And when I distribute the 2 to the right side, it yields 2 minus 4 cosine x plus 2 cosine squared x. This is going to be an equation that's going to have quadratic form. So I need to get all of the terms to one side. So I'm going to subtract 1 from both sides and add cosine x to both sides, which is going to yield, when I write it in descending order, 2 cosine squared x minus 3 cosine x plus 1. This factors into the 2 cosine of x minus 1, cosine x minus 1. And lastly, I use my zero product property. 2 cosine x minus 1 equals 0. Add 1 to both sides, divide by 2, yielding the cosine of x equals 1/2. And because they only wanted solutions between 0 and 2 pi, not all general solutions, I yield pi over 3 and 5 pi over 3 as places on the unit circle that have an x coordinate that's a half. My other factor, the cosine x minus 1, we set that equal to 0, add 1 to both sides, and the place on the unit circle where the x coordinate is 1 is at 0 degrees or 0 radians. When I verify this with my graphing calculator, we notice I have graphed the sine of the half angle plus the cosine of x minus 1, and we want to know where that equals 0, or the x-axis. So that is occurring at the origin, 0, 0, which is one of the answers we got. Another place is at 1.05, which if we expand this to the right side of the screen, pi over 3 is approximately 1.05 when rounded. And our other solution where it hits the x-axis between 0 and 2 pi is at 5.24, which is 5 pi over 3 when rounded. Enjoy your learning opportunity number 2, where I have written each of those assignments. I mean, ultimately it is 1 to 61 odd, but I've just sectioned it out so that you can identify the double angle problems, the power reducing, and the half angle.